So what is value data type? Value type variables can be assigned a value directly. They are derived from the class system.valueType. The value types directly contains data. Some examples are int, char, float, which stores numbers, alphabets, and floating point numbers respectively. When you declare an int type, the system allocates memory to store the value. Each value type has a fixed size based on its data type. For example, an int 4 bytes takes up less memory than a long. Long takes 8 bytes into the memory. This fixed size is crucial for memory management, especially in performance and critical application. So suppose you are declaring any variable and defining the type of it. So accordingly, memory would be allocated. So all integer data type variables, 4 bytes would be allocated into the memory, and for long variables, 8 bytes would be allocated into the memory. So during the programming, you need to think of it, what type of data that variable may contain. So accordingly, data type would be defined. So for memory management purpose, declaration of variable with the right data type is very important. So let's take the example of value data types. Integer my number is equal to 5. Here, int is a data type, my num is a variable, and 5 is the value assigned to it. Here, double is the data type, my double num is a variable name, and we are assigning the default value to it. So similarly, char, bool, and string, we have to declare like this. So here we have the list of value data type over here, and also the memory size would be allocated to it accordingly, and the range of the values to assign to that particular data type. So here byte, whenever we declare any variable of type byte, 1 byte would be allocated into the memory, and the value assigned to it should be between 0 to 255. So this is the range is allowed by C# whenever you declare any byte type data variable in code. So the next one is S byte, which also store or uses the 1 byte into the memory, and the range should be between -128 to 127. So we cannot assign any value bigger than 127 and less than -128 to S byte data type. So this is the memory size would be allocated into the memory, and this is the range which is allowed by the C#. So whenever you declare a float variable in C#, 4 bytes would be allocated, and the 7 digits precision is allowed. So only after decimal points, only the 7 digits are allowed when you declare any variable of type float. In case of double, 8 bytes would be allocated into the memory, and the 15 to 16 digits after decimal point is allowed. The next one is decimal, which occupies 16 bytes into the memory, and 28 to 29 digits precision is allowed. So in financial applications, this digits precision is very important for financial calculations. So these are the data types which are value data types and would be stored into the stack instead of the heap memory. So let's understand what are the value data types and what is the range of it. So let's understand with the help of this program. So here we have declared one byte variable, and the variable name is b, and we are assigning the value 255 to it. So as 255 is between 0 to 255, so it will not throw any exception. But as soon as you assign value which is not between this range, it will throw the exception. Yes, 0 succeeded and 1 failed. Constant value 256 cannot be converted to byte because it is the out of the range which was decided by the C# language. Similarly, each value data type has specific range, so we need to assign that value between that range only. So in case of double and decimal, memory would be allocated accordingly, but to identify whether it is double variable or decimal variable, we need to suffix the m to decimal variable, because both having the same value 5.01 and 5.01. So compiler may get confused whether it is double type variable or decimal type variable. To avoid that, Whenever you declare any decimal variable, you need to suffix the m to that particular value. So this tells the compiler that the number should be treated as a decimal and not a double value. We can modify variable values. So once you declare the variables in our code, you can modify it. So this is the declaration as well as initialization. After that, we can modify it. So this is also called as initialization of the variable. So here we are modifying the value of already declared variables. So we are just printing the values of b and I here. So let's run this application. Yes, program gets successfully run and we are getting the output of the application. Yes, value the B contains the 255 and I contain the 5896 and program gets successfully run. So let's understand this program. So in our program, there is a static void main method. So this is the entry point of the C# application. Here integer x and y variables are value types. So the data type is integer. So that's why x and y variable names are value data types. So in first line, integer x is equal to 100. So in memory, runtime environment will assign or allocate a memory to it into the stack. Suppose the memory address is 101. After that, here we are assigning the value of x to y. So instead of using the existing value, runtime environment will allocate separate memory to y and assign the 100 to y variable name. So the memory would be different in case of value data type. So x and y having the different memory location into the memory. So after that, here we are incrementing the value of y plus plus. So as the memory would be different, so only the y value would get incremented and x would be 100 only. So here we are just printing the x and y. So output would be 100 and y would be 101 because we are incrementing the value of y only. So runtime environment, all the value data types, separate memory would be allocated instead of sharing the same copy as we compare to the reference data types. So reference data types we can discuss in detail in further. So whenever you use value data types, separate memory would be allocated to each value data type. So as we discussed earlier, this program, now we have declared two variables x and y, which is of value data types. So the separate memory would be allocated. So x contains the value 100 and we are just assigning that value to y here. And after that, we are just incrementing the value of y. So x would be 100 only and y would be 101. So here we are just printing the value of x and y. So let's run this application. So this proves that separate memory would be allocated to value data type into the stack memory. So x is equal to 100 and y is equal to 101. So x is not get modified after the incrementing value of y. So here we have just incremented the value of y. Even we are assigning the same value to y with the help of x variable, different memory would be allocated onto the stack.